All right, this is Unit 2, Day 6a. We're going to look at graphing rational functions. And rational functions, the word rational, sometimes we forget exactly what that means, but a rational function just has, it's a function that has a numerator and a denominator. So the top is a function and the bottom is a function. So the most common, or I guess the simple definition of that would be that rational functions are ratios. Okay, so they are ratios of polynomial functions, So one polynomial function over another. So an example, just a quick example, even about making anything up. So just think of, so if I had y equals, you could say 2x plus 7 is one function, x squared minus 4 would be another function, and then write it as a ratio, or write it as a fraction, and there you go, you got a rational function. Another one, it could be a 1 on top, x squared plus, say, 3. So it's okay to have 1 on top. Now, if you have 1 on bottom, that's not considered rational. That's just a function by itself. But if you have 1 on top, 1 over that, then that would be considered a rational function. So let f and g be polynomial functions where g is not 0. So I can't have a 0 on bottom, because if it's 0, then you couldn't divide it, and it's not a function. It's not defined on bottom. So f on top, g on bottom, that would equal r. That would equal the rational function itself. So the most basic one, the most basic rational function is 1 over x. Okay, not a whole lot going on there with that. And make a graph to begin by, or make a graph to begin by creating a table of values. So just a quick, I say quick, but we'll pick quite a few here. We could start out with, say, -2, -1, 0, 1, and 2, and start from there and see, just kind of discover what's going on. So if I plug a -2 in here, that'd be -1/2. So -2, -1/2 is somewhere in there. If I plugged in a -1 in, that'd be -1, so -1, -1. If I plugged in 0, whoops, undefined. Okay, and that's actually going to be an asymptote. Okay, so it's not a hole in the graph, that's an asymptote. So there's this asymptote running up and down. If I plugged in 1, 1 divided by 1 is 1. If I plug in 2, that'd be a half. So I kind of see some things going on, but that sure don't show a ton. So let's keep going with it here. In fact, I might bring this down here, and I'll continue my XY table. Okay, so let's try -1/2. If I plugged in -1/2, 1 over -1/2. When you divide by a fraction, you actually flip it over. So that'd be a -2. So if I went -1/2, that'd be -2. And then if I went, let's say -3, so 1 over -3 would be -1/3. So this would be -1/3 down. How about -4? Well, that'd be -1/4. So I go left 4, and that's going to be even closer to the x-axis. Let's try 1/2. I plugged in 1 divided by 1/2. That actually equals 2. So if I go over 1/2, I go up 2. Let's try 3. If I plugged in, so that would be, 1/3. So if I go right 3, it'd be up 1/3. If I plugged in 4, it'd be 1/4. So it'd be right 4 up 1/4. Now, if I am going to really big numbers here, so say I want to plug in really big x values going to the right, that's going to be positive numbers. So if I have 1 over a really big positive, what am I approaching? Is it still something? So if I have 1 divided by 1,000,000, that's still something that's slightly above the x-axis. So I'm never really, I can't even make anything equal to 0 here. So I can't take 1 divided by anything and say 0. So if I had like $1 and I want to divide it among lots of people, everybody's going to get something, even though it might be less than a penny, it's going to be something. So it's going to be a positive number. So there's this asymptote going along here too, where I can't touch that. So this is going to get really close going down this way, really close, but never quite touching the x-axis. And there's an asymptote here. So it's going to go up, 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 really close, but never really touching the y-axis. Same thing on the other side. I'm going to get really close. So 1 divided by a negative is still going to be a negative something. It's never going to get to 0. I can't take 1 divided by any negative number and have nothing. It's going to get really close to nothing, but it's never going to get there. So it's going to go along that axis. There's going to be an asymptote there. And it's going to come down and go along this asymptote. So you kind of get the idea. It's that reciprocal graph. It's upper right corner, lower left corner. So let's go through and name some things. But if you want to try to fill this table, I'd pause right now and test yourself. This is we're trying to do all of the characteristics of a graph here. So the domain of this guy. So domain, I can plug in any number I want except for 0. So it'd be from negative infinity up to 0, and then from 0 to infinity. But 0 doesn't work there. Now the range, think up and down, I can get any number for an answer except 0. I can't divide by a number and it equals 0. So this is going to be basically the same thing, the same answer. Okay, and now the continuities. The graph is pretty continuous, except right there at 0, it has an infinite discontinuity. So it has an infinite discontinuity at x equals 0. So there's an infinite discontinuity. Increasing, decreasing, there we go, left to right. So as I go from left to right, it's going down very slow, and all of a sudden, boom, going down really fast. Then if I pick it up over here, it's still decreasing. This graph is decreasing everywhere except for 0. It's doing nothing at 0. So it's actually decreasing only. There is no increasing intervals. And it's going to be this answer again up here. So from negative infinity to 0, and then from 0 to infinity. The symmetry on this is one of those, it's not about the y-axis, it's not about the x-axis, but if I rotate it 180 degrees, it does have that symmetry about the origin. So it's an odd function slash symmetry about the origin. Boundness, is it bounded above or below? No, it goes up forever and it goes down forever also. Going up forever here, going down forever there. So there's none. It is not bounded. Extrema, any mins or maxes, and this one again is none. There's no local extrema, there's no global extrema because it goes up forever, so it never stops. And when we say extrema, we need to have a real number answer. So it has to be a real number, and we don't have, infinity is not a real number. Asymptotes, back up here a little bit so we can see everything. So the asymptotes here, I have two asymptotes. I have y equals 0 and I have x equals 0. So there's two of those. And then the end behavior, so I'm going to describe that, the limit as x approaches negative infinity and the limit as x approaches positive infinity is going to equal, well, it doesn't matter which way I go. If I go to the left forever, I'm approaching 0. If I go right forever, I'm approaching 0. Okay, so there's the characteristics of that very basic, that parent rational reciprocal function. Okay, so that is basic. That's the the basic one. Now let's flip it over, right? Crazy, a little bit crazier here. Some of these shifts are not so bad. Like this first one, you could probably, this would not be too difficult to graph. The problem is whenever you got, because that's a 1, there's no vertical, and then because this x down here, there's no vertical or horizontal stretching or shrinking. But when you get into here where this has a 3, now we got some stretching, shrinking, we got some stuff going on. So it does get a little crazier, and you get down here and this guy here, you can't really do it. So this, we could just say that this has a +3 on the end, so that is up 3 units. This has a -3 inside with the x, so minus means right. So you could just take that graph on the front, which it had the asymptotes were like a crosshairs at the origin. We'll go up 3 and go right 3. Make your crosshairs with it. And basically copy it, which all it was there was a point in this corner right here, and then it went that way, like that. And then there was a point right here, came along, the asymptote went through that point and went down. So that one you could do just fine. It's this guy, when you have that 3 on top, that messes things up a little. It makes it a little bit more difficult. We could, actually the next one over here too, this one wouldn't be so bad. This one, when it says negative, you could take we don't want a negative on the bottom. So if I took a negative out of both of those on bottom, that would be a negative out front, then x minus 4, which would be negative 1 over x minus 4. And all that would mean this minus 4 that's inside with the x, that would be 4 to the right. And then this negative would be flip about the x-axis. So those aren't too difficult. When these are 1s and the bottoms have 1x's, that's not too bad. So this one would just be right 4. So it'd be 1, 2, 3, 4. There's like my crosshair is what I call it. The crosshairs of your asymptotes. And then instead of being upper right, lower left, it's going to be upper left, lower right. So it's more like this. Okay, so now this one though, we're going to look at here. I don't know if this is difficult to remember, but that fireproof. Okay, so we got there our fireproof method where we had on the left side we had y plus or minus, and we had some number. Well, that number represented up or down. And then on the left side we had a vertical stretch, so vertical stretch or shrink. And the nice thing on this was because when we write it this way, number larger than 1 is a stretch, a number less than 1 was a shrink. And then on the right side, so this left side was all about vertical stuff, the right side is all about horizontal stuff. So, and a lot of times we just had, this was going to be a 1. And then on bottom, we would have x plus or minus something. So that number would be left or right. And then we have some number out front here. If something could come out, then that was the horizontal stretch or shrink. And if there was a negative in here, let me zoom in a little bit. I feel like I'm too far away. If there was a negative in here, then that would be a flip about the x-axis. That would flip it over. So if you had a negative sign there. So this guy right here, if I want to write this in, quote-unquote fireproof method, first off, I need to have a ratio on the left side and a ratio on the right side. So if I make this a y, I got to bring that 2 over. So it'd be y plus 2. And then that's going to equal, and right now, well, that would be, I could put this over, but I really want this to be a 1. So to make that 3, to make this a 1, I'd have to divide 3 to the other side. So this would be a 3 on this side. Negative can stay, and then I got x minus 2 on bottom. So what I got here, and remember the whole left side has to do with vertical stuff. Vertical stuff. So this is, that plus 2 means 2 down. And then this 3, it's larger than 1, so it's going to be a stretch by factor of 3. So stretch by 3. This negative means flip the graph over about the x-axis. If it was a negative over here, it would be about the y-axis, but it's over here, so it's about the x-axis. And then this minus 2 here means 2 to the right. Okay, so I'm going to do these first. So 2 down, 2 to the right. So 2 down, 2 to the right. Here's like my crosshairs. And then instead of being upper right, lower left, I got to be upper left, lower right because of the flip. And now everything gets stretched by 3. So that first point originally was up 1, left 1 from like the crosshair. Well, this one's going to be stretched by 3, so it's going to be up here, 3 units. Okay, and everything is going to get stretched this way. So it's going to come up along there, and it's going to take off like that. And then over here, this was normally 1 point. So if you take the crosshair, go down 1, right 1. Well, this one's going to be down 3, right 1, because they got vertically stretched by 3 units. So it's going to come down like this and go through like that. Okay. So that 3 just meant stretch it vertically, stretch everything out vertically. The last problem now. So what happens when the function's not in the right form? So what we want to do, if we can get it into a form that we can read, and hopefully it'd be nice if it was in that fireproof form, what we got to do is let's actually just divide those. Okay, so I'm going to divide these guys. I'm going to take 3x minus 7 and divide it by x minus 2. Okay, so 3x divided by x is 3. So that'd be 3x minus 6. Remember, when you're actually subtracting straight down, it's got to do the opposite. So you get negative 1. Write that as a fraction. So it'll be minus 1 over x minus 2. So now my function is going to equal, and if you want to write it like this, that's actually a positive 3 on the end. So I could put plus 3 on the end and have a negative 1 over x minus 2. So right off the bat, in this one, I don't really need the fireproof form because that's a 1. So I don't think it's just as easy to do number outside by itself is 3 up. Number inside with x, left, or negative 2 would be right. You'd think left, but it's actually right. And then this negative means flip it. Flip it about the x-axis. So my crosshairs were right here. I'm going to go up 3. I'm going to go right 2. There's my new crosshairs. Instead of upper right and lower left, I'm going to be upper left and lower right. And the vertical stretch on that is a 1, so that means nothing, means change nothing. So it's going to be up left 1. There's one of your points. Go along the asymptotes, and this one come up along the asymptotes and go that way. Okay?